Okay, now recording. Okay, so let's start off with section B, question 1. So, a stone of mass 3 kilograms is fastened to the end of a length of string. The stone is then whirled round in a vertical circle of radius 1.1 meters. The stone moves at constant speed with a time period of 1.5 seconds. So what you have here, oh sorry, I'm going backwards. Okay, what you have here I'll just draw it first. You have a stone and it's being twirled around. So it's going like this. There it is at the bottom, there it is at the top, and it's going around and around like that. And the radius is 1.1 meters. The mass is 3 kilograms. And the time period is 1.5 seconds. And he asked for the angular frequency, or the angular velocity. The omega is what he wants. Well, I think, I'm sure it's in the formula book, but the formula I'm going to use is T equals 2 pi over omega. Right. See where that is for you. That is on the bottom of page 3. So omega equals 2 pi over t, which equals 2 pi over 1.5. Daniel, would you be able to put that in your calculator? 2 pi over 1.5. .19 radians a second. Okay, that was part 1. Now part 2, also straightforward, the velocity. So he wants the v, which we could use omega or, I think, since we have omega and we have or. So again, if you look at the bottom of page 3, you can see, omega equals v over or. Omega equals v over or, so v equals omega or, which will equal 4.19 times 1.1. Again, Daniel, what's that?
4.619.
What is it?
4.619.
6.1, sorry. Now, the next thing he wants is the tension in the string when the stone is at the top of the circle. So when it's at the very top, what are the forces acting on it? There'll be 2 forces, won't there? There'll be the tension and what else? Also the weight. Yeah? So there'll be the tension and there'll be the weight acting on it. Now, we want the tension. The weight's not going to change. Let me just make sure I get the sign the right way around first here. At the bottom. Yeah. Which do you think has more tension? When it's at the top or when it's at the bottom? Because we'll need to do the bottom as well after this. When it's at the bottom, the tension is acting this way, and then the weight is acting this way. So the tension will be bigger at the bottom. Let me show you what's going to happen. At the top, there's two forces acting on it, the tension and the weight. He wants the tension. Do we know the weight? We do. But what we also know is what type of motion is this? Circular. So we know that this force should equal the circular force. We have a couple of formulas. We should use the one with the omega and the or in it. Wait. Seriously, why are you half an hour late for class?
We went like 1 hour ago to the printing for the maths project, and then we started printing, we printed out, then we checked it.
I should also point out whatever you're going to say is being recorded. Yeah, so make sure it's the truth.
It's the truth.
Yeah.
I've got a witness over
Yes?
Yeah.
Alright, please do not trip over anything as you sit down. You can come around this way. You're missing section B. Take out your exam. Okay. I'm going to use the formula that they give me in the formula book. We could use the m omega squared over. He doesn't actually say that. He uses another one. V squared over r. Which is okay too, because we've worked out the v. Okay, so the tension will equal m, which is 3, v squared, which is 4.61, over r, which is 1.1, minus the weight, which is m times g. Okay, so that's the tension.
B1 then?
This is B1 A part 3. Thank you. What is it? 28.5 newtons. Now, the next part is he wants the tension at the bottom. So the only difference at the bottom is, you see, the circular force is caused by, the circular motion is caused by the tension, but the weight is taken away from it. So this will end up basically making the tension bigger. So the only real difference is, instead of adding them like I do at the top, I have to subtract them. So the weight is removed from the tension. So the only difference here is, I don't even have to rewrite it, that's a minus, which makes that a plus. So the answer will be 4.61 squared over 1.1 plus that. And calculator, please. What is it? Thank you. Now the next part he wants is the acceleration, which is so easy again, because we almost nearly did it already. The formula for acceleration is v squared over r. This is also in your formula book for circular motion. The v squared, there it is, and the r, there it is. So what's that now? What is it?
19.32.
3.2? Okay. Sorry, I need to get out of the habit of not writing so big, because I know you can see it. Right. V part 1, explain why the stone is accelerating, even though its speed is constant. Well, acceleration equals, what's the definition of acceleration?
Change in velocity or
change in velocity over change in time. So I'll just write change in velocity per time. But what's velocity?
speed.
It's change in speed or direction. Well, velocity is speed and direction. I'll write that down. Speed with direction. Oops. Okay. So, if the direction changes, then the velocity changes. And if the velocity changes, then you have acceleration. So in other words, it's accelerating because its direction is changing. Okay. Now, B part. A stone of 3 kg is held over a well 151 meters deep. Determine the time until a person next to the well hears the sound of the stone hitting the bottom of the well. Hey, where have you been? No. Where have you been? Yeah, continue. Maths, that's where you've been. Disappointed. Who are we? We're still waiting for Omar and Brandon too.
Brandon is out.
Oh yeah, and Omar?
Still printing.
Still printing.
Yeah. No,
Right.
because sometimes the equations, when you print it, doesn't show up. That's why.
Okay. Shouldn't have left it to the last day. Alright, so you have your guy here. He has his stone here. And he drops the stone, goes down, crash. And when it crashes, the sound travels back up. So the question is, how long until he hears the flop at the bottom? So there's 2 things you need to consider. The time it takes for the stone to fall, and the time it takes for the sound to come back. So firstly, the time to fall. Well, what's U? 0.
Yeah.
V, we don't know. Don't care, actually. S,
Is
151, and A, 9.81. So we only want T, so will V squared equals U squared plus 2AS? No. S equals UT plus a half AT squared. Yeah, that one. S equals UT. Oh, by the way, I should write down the formula I'm using. S equals UT plus a half AT squared. Okay. UT, which is 0, plus a half A, which is 4.905.
4.9.
Is that right? Well, it's 8.1 actually, you see. What?
4.91.
Are you sure?
4.905.
Yeah, that's what I thought. 4.905. A half A T squared. So if I want the T, I'll just divide that underneath that, and then take a square root. Okay. So that's my T. Okay, what's that equal to? About 5 seconds or something, what is it? Take out your calculator, please.
5.55.
What is it?
5.548.
548. I want to be more precise for this one because I imagine the time for the sound to be quite small. So 3 decimal places, 548?
Yeah.
Okay, 548 seconds. Now, what happens next is the sound travels back up. Is the sound accelerating?
No.
No, so we can just use our simple distance, speed, time triangle.
But it says the velocity of sound in the air is 3.0
Yeah.
meters per second.
Yeah. So we want the time.
Oh,
So the time is the distance over the speed. So the time for the sound is the distance. That's actually bigger than I thought. Yeah. It's about half a second. What is that?
0.444.
Okay. So the total time equals 5.548 plus 0.444. What's that? 5, maybe 6 seconds?
5.992.
5.992, okay. 6 seconds. between releasing the rock, the stone, and hearing the blob. Oh, this is so easy for babies. Right, that was B part 1. The next part is, what's the velocity? So what formula will I use? The velocity of the stone at the end? V equals U plus AT. What's the U here?
0.
What's the A?
9.8.
And what's the T? Be careful.
5.992.
No.
Right.
No. No, 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 no. 5 point.
Oh, 5.548.
What's that?
For
54.2 meters per second. And finally, the kinetic energy. What's the formula for kinetic energy?
Half mv squared.
The mass is 3, so half the mass is 1.5, and the v squared is that, which equals... What is it?
4439.
4439.04. So we'll just say that. Joules. I'd say that question took 20 minutes. Would you say? 20, maybe 20, we'll say. Such a nice question.
20 minutes? Like one question? Like in real exam?
Well, it depends, I don't know, if you panic in the real exam.
Definitely.
You'll probably read it a few times to make sure you understand it properly, but such a nice question. Such a nice question.
Eight
Now-
questions only, right?
Yep, only.